So what's up, guys? It's been a while. I've been busy with other projects, but I thought I'd give you a little taste of what we're doing now. Now that I have some time and I could catch up on working on the CRX. So here we have our mocked up CRX. But what we're going to end up doing is we're going to create a strut tower brace, which is kind of similar to what a strut tow bar brace is. The one, you know, what you normally see on most vehicles where you bolt on across the two strut towers, or the two struts. Man, I'm having a hard time. But because this is a double wishbone suspension, most Hondas have a double wishbone suspension. It's not really effective. It does help aid. It does aid a little bit, but not really. So if you really want to get into the nuances of how they work, I suggest go hit up Engineering Explained, and he does a very good job of explaining what it does. But what we're going to do is try to eliminate the flexion of the strut tower due to the spring compressing, or when you're hitting cornering, it pushes everything up. So we don't want this to move up. So we're going to create a brace that ties into the door jamb. So by tying into the door jamb through this hole right here, and how we're going to accomplish that is I have this solid stock of steel. I am going to cut it to the appropriate length. I'm going to make this hole, utilizing this hole, I'll make it slightly larger with a step bit so I can fit a 1-inch stock, and I'm going to drill and tap a hole right there and make this a mounting place. So I'll slide it through. There's also a hole on the other side that you have to drill out. Slide it through, weld both sides of it, and now there's one cohesive unit, one unit. I'm also going to use the door jamb as my other two mounting points, because this is also a structural point of the vehicle. It's extremely solid, so I'm just going to make brackets that get sandwiched by these two bolts here, and I'm also going to change out that hardware. Once those brackets are made, I'm going to use tubes to tie both of these guys together, creating one cohesive unit. So that therefore eliminating the vertical forces that are going to be introduced by the tire when turning, or mainly when turning. So when it's leaning, I'm going to get on making these attachment points. So next time you see me, you probably see this welded up. Out of our stock, it's all welded up. Right here we got a bunch of gummy shit that I had to cover up because I was trying to TIG it. There's so much wind because I'm outside that I couldn't get it proper, so it just made shit. So I had to fill it all back in, and I'm gonna have to grind it down to make it look nice. Fully welded inside too, so it goes into the inside. As you can see, we got welded there. Same thing on this end, right there. So he's all welded up. Hey, so I forgot to turn the microphone on the camcorder when I was recording this, but I have this prototype here, and what I'm going to do with this prototype, I'm going to use the existing holes to locate my mounting holes. So I'm going to drill and tap right here on the table. See how I'm marked out? And I'm going to mount the new brackets individually on the table. Then I'm going to take tube and tie it all together. I'm also going to take this 1.5-inch stock and make a new tube bracket where I'm just going to counterbore a hole for an Allen bolt. So Josh is going to be taking care of that, and I'm going to move on to make the brackets. Alright, so here's our first tube bracket. The hole's countersunk, big enough for an Allen 1/2-inch bolt to fit through there. There's our old one where I was using a 1/2 inch bolt, but I had to use a bigger piece of tube for a socket to fit over the 3/4 inch head. So I decided to switch it up to this lower profile, and it's stouter too. Let's see how it looks with a bolt set in place. See how nicely it gets recessed in there. It's a stainless steel bolt. That's the same exact bolt that I'm going to be using. Now if I just tighten it down, you'll get a real good look at how it will look on the vehicle. Look at that. It's nice profile, clean look. Much better, and it's easier to install too, because you just put it on the end of the Allen head bolt. Okay, now I'm going to have the CNC plasma table cut the brackets out that mount to the door jamb. And just like that, a plasma table is done cutting out the 4 brackets. As you can see, I left the pinholes there. That's to locate where my mounting holes are going to be, and also the recessed cuts to fold it. So now I need to drill out those holes. I'll mount them on and weld them up. Okay, so here I have the tube that's been coped and cut to length. Actually, it goes in this orientation. He's just sitting there. He's ready to get welded. I also took a piece of filler rod and I bent it to the angle that I needed it, where I wanted the bend. I mainly did this to, 1, figure out what my angle of bend needed to be, and 2, so I knew where the center of the bend needed to be. Another thing I did is I marked it to the adequate length, or the appropriate length, and that way I could just pull a measurement and I know exactly how much tube I need to bend to accomplish this. So this gives me both the location, the length, and the angle. It's a very useful way of figuring out what you need, especially on a jig like this. So I don't really know the angle. Let's see if we can figure it out. I got my angle finder here. I will lay it, get them straight up and down. Looks like about a 40-degree angle. So that's what I need, is a 40-degree angle. Now I will cut a piece of tube and figure out what I need, where I want my bend to be, and then I'll put it on the tube bender and we will start bending tube. Okay, so here we have our bent piece. And now we don't. So as you can see, this is how it's going to look. Eventually, so now I need to cope it, and then I'll cut this side. And by coping I mean a C notch it, or however you wish to label it. So I'm gonna mark that in there, and I'll C-notch it. That lets me know that's where I want it. So the reason why I marked that there is so that when the hole saw comes in, I know where to hit it. Because otherwise I could roll it up, I could roll it down, but if I hit it, that'd be perfectly perpendicular to the tube, as long as I orient this right. So I'm gonna do that. I'm gonna do that with both sides, and then I'll end up cutting it, and then I'll tack everything up. I'll unbolt it. I'll take it to the vehicle, test fit it, and then come back and put it back on here, and then finish welding it. Okay, so here we have our first one just completely mocked up. I still need to tack it and weld it, but I figured I'd show you guys how everything is coped and how it basically look. Because you know, I even get grow with anticipation when I watch things like this, so I figure I'll let you guys see the product before it gets welded in and not have you guys wait. So here it is. So now what I'm going to do, I'm going to tack them all together and then see if they fit. Hopefully it all works. And here we have the finished product. So I'm pretty happy with the way it turned out. So now I'm going to bolt them up, see how it